Bismillahirrahmanirrahim. In our today's lecture, we will discuss about the numericals of chapter number 3. A laser beam is directed from Earth to the Moon. The beam spread over a diameter of 2.50 centimeter at the Moon surface. We should find the answer according to book. So, we use diameter of beam S is equal to 2.50 meter, not in centimeter. When we use this value, S is equal to 2.50 meter. So the answer is according to the book. We have to find the divergence angle, and the distance of the moon from the earth is 3.8 into 10 to the power 8 meter. As we know that S is equal to r theta, so theta is equal to S over r. By putting values of S and r in above formula, we get this, and after solving it will be equal to 0.657 into 10 to the power minus 8 radian, which can also be written as 6.6 into 10 to the power minus 9 radian. This answer is according to book. Numerical number 3.2. A car is moving with the speed of 108 km per hour. If its wheel has a diameter of 60 centimeter, find the angular speed in radian per second and revolution per second. So the given data is V is equal to 108 km per hour, which is converted into meter per second by multiplying it by 1000 and dividing by 3600. So V is equal to 30 meter per second. Further, it is given that diameter is 60 centimeter, which is 0.60 meter, and we have to find the radius because it is used in the formula of angular speed. So R is equal to 0.30 meter. We have to find angular velocity, means omega in radian per second and omega in revolution per second. Solution. As we know that V is equal to R omega, so omega is equal to V over R. By putting values of V and R in above formula, it will be equal to 100 radian per second. So the first answer is 100 radian per second. We can also convert it into revolution per second, as we know that 2 pi radian is equal to 1 revolution. So 1 radian is equal to 1 over 2 pi revolution. Multiplying the above answer with this factor, then it will be converted into revolution per second. 100 multiplied by 1 over 2 pi revolution per second. We know that the pi is equal to 3.14. So omega is equal to 16 revolution per second. Numerical number 3.3. An electric motor is running 1800 revolution per minute. On switching off, it comes to rest in 20 seconds. If angular retardation is uniform, find the number of revolution it makes before stopping. So the given data is omega I, initial angular velocity, is equal to 1800 revolution per minute, which is converted into revolution per second. So it will be equal to omega I is equal to 30 revolution per second. Further, it comes to rest. So omega f is equal to 0 and time is 20 seconds. We have to find the number of revolution it makes before stopping. So theta is equal to question mark. Solution. As we know that S is equal to Vt, but in angular motion, theta is equal to omega average multiplied by t. Omega average is equal to omega I plus omega f divided by 2 multiplied by t. By putting values in above formula, it will be equal to theta is equal to 300 revolution. Numerical number 3.4. A string 0.5 meter long holding a stone can withstand maximum tension of 35.6 Newton. Find the maximum speed at which the stone of 0.5 kilogram can be wheeled with it in a vertical circle. So the given data is length of the spring is 0.5 meter and mass maximum tension T maximum is equal to 35.6 Newton. Further, mass of stone is equal to M is equal to 0.5 kilogram. We have to find the maximum speed. So V maximum is equal to question mark. Solution. As we know that the maximum tension in a vertical circle occurs at the bottom. So for vertical loop, let's say this is the string and red color represents the stone. Its weight is downward, which is equal to mg, and tension is upward, so T is equal to upward आ गया. Also the stone is wheeled in a circle, so the centripetal force Fc is acting on it. So maximum tension is equal to centripetal force plus weight. The formula of centripetal force is mv square over r. We use V maximum and the weight is mg. Solve it for V maximum. So V maximum square is equal to T maximum minus mg multiplied by r over m. V maximum square is equal to putting values of T, m, g, r and other factors in above formula. We get V maximum square is equal to 30.7. We have to find V maximum, so taking square root on both sides and it will be equal to V maximum is equal to 5.5 meter per second. So the maximum speed of the stone is 5.5 meter per second. Numerical number 3.5. A flywheel of an engine is rotating at 2100 revolution per minute. When the power source is shut off, what torque is required to stop it in 3 minutes? The moment of inertia of the flywheel is 36 kilogram meter square. So the given data is angular velocity of flywheel is equal to 2100 revolution per minute, which is converted into radian per second by multiplying it by 2 pi and divided by 60. So omega I is equal to 220 radian per second. Further, it is given that the power is shut off, so omega f is equal to 0 and t is equal to 3 minutes, which is converted into seconds, and it is equal to 180 seconds. The moment of inertia of the flywheel is 36 kilogram meter square. We have to find the torque. As we know that in angular motion, torque is equal to I alpha. Further, alpha is the angular acceleration, which is equal to omega f minus omega I divided by t. Putting the values of alpha in above formula, so tau is equal to I multiplied by omega f minus omega I divided by t. By putting the values In above formula, we calculate the required torque and it will be equal to minus 44 Newton meter. But negative sign indicates that the speed is decreases, that is retardation. So the required answer is torque is equal to 44 Newton meter.